Hello and welcome to this week's very special episode of the Entrepreneur Interview Series presented by the Undergraduate Entrepreneurship Association at Carnegie Mellon University. Today I am pleased to be joined digitally by a very accomplished and ambitious alumnus of CMU. My guest today was named the 2019 CEO of the Year by the Pittsburgh Tech Council, but more importantly, he is catalyzing rapid progress towards space exploration and lunar colonization as CEO of Astrobotic. Astrobotic is a lunar logistics company and a lunar payload specialist capable of delivering payloads to the moon for governments, corporations, organizations, and individuals. Astrobotic's Peregrine and Griffin landers have the capacity to deliver payloads to the moon at historically low costs. Astrobotic was spun out of CMU in 2007, and now it is planning for its first payload delivery to the moon aboard the Peregrine spacecraft for NASA and many other customers in 2021. Again, it is my pleasure to introduce the CEO of Astrobotic, Mr. John Thornton. It's a pleasure to speak to you today.
Well, thanks so much for having me on. Appreciate it.
Sure thing. Thank you very much. And let's start with the very basics. Can you please explain some of the general operations of Astrobotic and really what mission you seek to achieve with this firm?
So Astrobotic is a lunar delivery services company focused on making space accessible to the world. So that first big program is making the moon accessible by building that delivery service. So we have two landers, our smaller lander Peregrine and larger lander Griffin, now both with missions that are going to be headed to the surface of the moon. And what we do is provide an end-to-end delivery service for payload customers all over the world. So scientists and space agencies and even commercial corporations can send packages up to the surface of the moon, and we will send them up, operate them, and send their data back home for folks back here on Earth.
And starting from the very beginning, Astrobotic was spun out of CMU, but how do you start a business in such a difficult field as space robotics?
Yeah, that was an interesting one. So we started in 2007 out of Carnegie Mellon. So at the time, I was a student that was just graduating with my master's at the end of 2007. And we got started initially because of the Google Lunar X Prize. And I was working with Red Whitaker over at the CMU Robotics lab. And he had me working on a rover that was designed to drill for water at the poles of the moon. And it was just a concept rover at the time. 13 years later, that ended up being the same kind of payload that's going to be sent on our mission that was just announced last week. So it's very cool that was full circle. And Red really had the front end thinking on getting that whole thing built up from the get-go. So back in 2007, right around that time, came out the Google Lunar X Prize. So that was to be the first to go to the moon, drive 500 meters, send back pictures and video. And that's when Red and a few of us got together and said, hey, let's start a team. And that was the birth of Astrobotic. So we went through a lot of tough times in the early years and then managed to stabilize eventually. And we managed to grow. I started on the engineering side of the company, and then about 8 years ago, moved to the business side and took over the reins of the company. And we tried to stabilize and grow on technical contracts for many years. And then the last 2 years have been really big for us. This year, of course, with our $200 million contract from NASA. Last year was our breakout year with an $80 million contract from NASA to send another mission to the surface of the moon.
Right, and let's jump up to that current event you mentioned. You received a $200 million contract from NASA to send that Viper lunar rover to the south pole of the moon, correct?
That's right.
And what are those contract negotiations and those contract bids really like, and how are you able to compete with other large corporations like SpaceX and Blue Origin and Lockheed Space?
Yeah, great question. So CLPS is a commercial lunar payload services program that NASA has, and that's where this program is out of. We compete with 14 other teams that are part of that program, and they include all the vendors you just talked about, including many others. So competing in that field is very challenging. We're competing heads up against folks that have been in the business for decades from the very beginning of the dawn of spaceflight. So it really challenges us on every level and every aspect of the business. So when these proposals are put on the street and the request for proposal is put on the street by NASA, we have an opportunity to write the best proposal we've ever written. And we did that on this last one, and we came out on top, and we are so thrilled and honored to have done that and to have an opportunity to take a nationally important mission like this to the pole of the moon.
You're sending a lot of instruments to the moon for measurement and to collect data and all sorts of things, and really to explore the moon. Now, I think when most people think about the moon, they just imagine rocks. It's probably not very interesting to them. But what sort of data are you hoping to collect from these sorts of missions?
The big win from this mission in particular would be to find water at the poles of the moon and understand what concentration and how it is mixed into the soil or not at the poles of the moon. So the poles of the moon are naturally one of the coldest places in our solar system. The pole of the moon can get down to single-digit Kelvin temperatures. So that naturally acts as a cold trap to attract different materials to go directly into their solid form rather than turn to liquid or gas and effectively evaporate into the blackness of space. So these cold traps at the poles are thought to have huge amounts of water that could potentially be turned into rocket fuel, because you can take water, you can split it into oxygen and hydrogen. That's the same fuel that powered the shuttle. So if we can find water at the pole of the moon and then figure out how to turn that water into rocket fuel, we could potentially have a massive groundbreaking breakthrough in development of space, because that would be the first time we would be using locally sourced materials to further our exploration and development of space. So it gets further and further towards the point where we can learn to live off the land of another planetary body in space and become true explorers of our solar system.
All right, so jumping pretty far ahead, if that is to be the case and we can safely colonize the moon fairly soon, do you present or support any particular political system for the allocation of land on the moon, and how does space law factor into that decision?
That's a complicated one. So as of now, there is a space treaty, an international space treaty, and also one around the moon. So you can't claim land on the moon, but there is recent legislation and work in both the U.S. and also Luxembourg towards the idea of owning the resources that you extract, to try to enable and encourage commercial companies to potentially set up shop making lunar rocket fuel, for example. So it's just first steps, and I think there's a lot more that we need to learn about what the business models are going to be before we establish law, because we simply don't know how business is going to operate yet, and we just kind of have to figure that out first, and then policy and law will follow. And the same kind of things we've seen in space. The first space stations, we didn't establish those rules, but now with the International Space Station, where you have folks from different nations interacting, there are rules around that, depending on which part of the station you're in. It's different rules. So we could use the same kind of pattern, but we have to go and figure out what's up there, how to do business, because it literally is the extreme edge of what we can do as a species commercially. So we need to kind of leave a little room for that development and innovation.
And also with colonization in the current topic, your first location for your first launch next year, Locus Mortis, has what appears to be quite a large lunar cave near it, which would be very helpful for colonization. Can you talk about the potential benefits of that?
Yeah, absolutely. There's a few key hotspots and geographic features on the moon that I think will be destinations for future human settlements, and one of them is caves. As you mentioned, our first mission is landing in the vicinity of, unfortunately not close enough to drive up to it, but close in the vicinity. But what's unique about a cave on the moon is it provides natural protection from the elements. So it's just like caves here on Earth. The elements that you need protection from on the moon is you've got radiation that comes from the sun. There's no magnetic sphere that protects the moon like the Earth has, that deflects a lot of that radiation. So all that radiation comes straight down. You also have thermal extremes that are quite severe because there's no atmosphere. You get 120 degrees Celsius during the day, or about 250 degrees Fahrenheit during the day, and then it drops down to liquid nitrogen cold at night. So it's minus 180 degrees Celsius, super challenging environment. And then the other real challenge is micrometeorites. So there are meteorites that regularly impact the moon and regularly fly through space. I mean, there's even holes in some of the solar panels of the International Space Station. And when you're on the surface of the moon, you can't move like you can with a spacecraft. So if you're protected underground, that protects you from the radiation, the thermal extremes, and the micrometeorites. So it could be a very, very compelling destination. So that's one hotspot. The other hotspot, of course, is the water. So the trifecta would be somewhere at the pole near a source of water, so you can make rocket fuel. In a cave, so you've got natural protection from the elements. And then third is if you had a peak near the pole, and that's important because you could potentially get year-round sunlight at that peak. If you found that location, that's where you'd want to set up camp, because that you'd have all the essentials for supporting a base.
Now let's talk about how individuals can get involved. Can you explain a little about your DHL Moonbox system and how individuals can take advantage of that?
Absolutely. So our goal as a company is to make space accessible to the world. And towards that, we've, I think, got a good start toward having space agencies access the moon at price points that have never been possible before. We are going to be very nearly tripling the number of nations that have ever operated payloads on the surface of the moon just with our first mission alone. So we're well on our way there. But we also want to make it possible for the individuals, folks like you and me as individuals, to access the moon. So we have a program called DHL Moonbox, where for starting at a few $100s, folks can send mementos up to the surface of the moon in a time capsule. So we actually have inscriptions from people. We have photos of families. We have actually some pet hair from a family pet that passed that will be sent up. We even have time capsules that students have put together, like a classroom or even a whole school that people contribute to. But what's really fun about that is it's a permanent place on the surface of the moon that people can always look up to and know that there's a part of their story forever intertwined with the moon. And the moon is something that unifies us all. It's in the night sky every night. And no matter where you are on Earth, you can see the moon.
Very cool. Are you or any of the Astrobotic employees sending anything individually to the moon?
So I haven't decided what I'm going to send yet, but we are planning to have something for the employees that we can all get up there. Not sure what that will be yet, but we've got plans.
Very cool. Very cool. What was your student experience at CMU like?
CMU was great for me. I studied mechanical engineering, bachelor's, master's mechanical engineering, but one of the biggest things that I think added to my education was the buggy program. So I got very involved in fringe racing at CMU. I was the head mechanic, built 3 buggies myself there, and contributed to another one in my freshman year. That gave me a real great opportunity to work with teams, doing tough engineering challenges, and learning leadership and learning the ins and outs of running a complex technical system like that. So it was a great launch pad to not only career opportunities, but also, of course, meeting Red Whittaker and getting started in the robotics lab, building up that Scarab rover, which was of course, the launch pad to everything that happened afterward.
Why does Astrobotic choose to remain in Pittsburgh, of all the places on the planet to pursue space robotics?
So we like Pittsburgh because of its robotics talent that's coming out of Carnegie Mellon and other universities in the area. That is a unique advantage that we have, and we like to think that we home grow robotics and we import space and we mix the two together and you get world-class space robotics. And that's going to be our special sauce for decades to come. And then it also helps that we all really like the city. It's a great place to grow a business, affordable quality of life. You don't have to make a ton and you can live like a king here. So it's a really, really, really nice place to be and to grow a company and eventually family.
You mentioned that CMU is also a big part of the robotics atmosphere in Pittsburgh. What's the ongoing relationship between CMU and Astrobotic currently?
We have a strong partnership with Carnegie Mellon, led by Red Whittaker down in the robotics lab. So he has a rover that will be flying on our first mission, and that rover will be the world's first university to ever operate or send a rover to another planetary body. That one's going to go on our mission next year. And I know he's got lots of students are involved in that project, and I'm sure he's looking for more. So please reach out to Red Whittaker down in over in the robotics department. He wants your help. And then the next one is he's got an even larger rover that's going to be sent up in 2022. That rover is called Moon Ranger, and that one's more about building an autonomous rover that can demonstrate autonomy, because at the poles of the moon and other destinations at the moon, you might drop out of communication with Earth, and you need some level of autonomy to be able to reestablish that comm and get that back. So those are the two big flagship programs that RED has going at Carnegie Mellon. And of course, we have a more than decade-long partnership with CMU and RED that's been very fruitful for both of us.
Now, a lot of these rovers that we're sending to the moon and other places, they have a very limited lifespan because of the harsh conditions of those places. How do you get the most science and the most data out of those technologies and out of those rovers in those time periods?
Yeah, there is a limited timeline for the rovers, and it's primarily limited because when the sun sets, you get down to liquid nitrogen cold, and most of the systems on the land or on the rover will have a hard time surviving that because it stays cold for 14 days. So it's not like you can just turn a heater on for a little bit. You need a lot of power to do that. So the way other robots have done this in the past is they bring a radioisotope with them, i.e. a piece of nuclear material that's hot. And you keep that on board, and you use that to circulate the heat and kind of have like a warm electronics box is what they often call it. So for small rovers, like the rovers that Carnegie Mellon are building now, it's too difficult to have enough power stored on board. And it's also difficult to bring a radioisotope because you need presidential authority, and a huge budget is just not feasible. So then the big question is how do you get the most value, and that's where the autonomy question really comes to the head, and that's where Red's shop over at Robotics is really one of the best in the world at that for cutting edge autonomy. So if you can basically speed up the travel time, the time between command and getting to another destination, and make autonomous as much of the sampling and acquisition and other tools you might be doing for part of the science process, the better. So I think it's a key aspect to enabling a maximal science output from a small rover.
Now, obviously, there's a lot still to discover on the moon, but what other places in the solar system do you think there are important discoveries to be made? Obviously, there's a lot of discussion about Mars, and also a lot of discussion about some moons of Jupiter, but what really do you think we should be looking for in other places in our solar system?
Well, certainly, I think what we need to start with is the moon. And the reason for that is that is the closest destination to Earth, and the place where we're going to develop the technology and the capability to use local resources to further the exploration or the science or whatever the objective might be. So if we can learn to harness rocket fuel from the moon, we could use that same technology on Mars or at other deep space destinations to refuel our spacecraft. If we can learn to 3D print materials, for example, or replacement parts even from local lunar regolith, we can use that same technology on Mars and other destinations deeper in space. So I think that's the starting point to open up these other possibilities, and then you can more easily get to Mars, explore the caves on Mars, for example, that maybe could have some life there. Who knows? Explore the deep oceans of the moons of the outer planets. That'd be incredibly exciting. But you need the building blocks. You need the capability built up over time. And I think that's why spending a good amount of effort here on the moon and learning how to operate in space is just so critical to get out deeper and deeper into our solar system.
Yeah. So when we get to the point of lunar colonization, who do you think are the ideal candidates to be part of the first lunar colony, and what do you think they'll be doing during their days there?
Well, it's probably going to be very similar to the astronaut program. You got to get your best and brightest and most level-headed folks up there to make sure that they can do the right thing at the right time and react in risky situations with the right response. And that takes a lot of training and a lot of effort and a lot of studying and book smarts to solve problems that are outside the box. But I think the first astronauts up there are going to probably be doing a lot of science. And then in time, potentially being involved in some of the extraction of materials and development of new processes to push the bounds further and further of what we can accomplish up there. So I think the astronaut and robotic partnership is going to be a key part of developing not just the moon, but also deeper destinations in space. So that human-robot interaction, which is another area that CMU is very strong in, is going to be a key driver for the future.
In working toward that lunar colonization goal, what is your dream contract to receive from the government as CEO of Astrobotic? What's the best possible thing you could receive from them?
Well, I got to say, my birthday is this month, and winning the Viper rover mission this month was about as good as it gets. So I'm sure over time we'll want more and more mission opportunities. But right now we are just so thrilled and so happy and grateful for this great opportunity.
And what exact parts of the operations and the delivery of the Viper rover does Astrobotic take care of?
So what we do as a company is we provide an end-to-end service for our customers. So NASA will build the rover, send it to us, and then once we have it, our job is to put it on a launch vehicle, send it up to space, and fly it out to the moon and land it safely. So the way we do that is we will go buy a launch from a launch provider, commercial launch provider. They will get us up to space, and then we build the lander that goes on top of that. And that lander is kind of like the delivery truck, the last leg delivery truck, if you will, that takes their payload from vicinity of Earth, but on a trajectory to the moon, out to the moon, descend down on into lower orbits around the moon, and then descend lightly and softly for a soft landing down on the surface. Once on the surface, for the Viper mission, our mission is fairly short. Once the lander deploys the rover and the rover drives off, the mission is complete. For the first mission, we will be operating communications and power systems for the payloads for a much longer time.
Can I ask you, do aliens exist? And if so, do you know any yourself?
If you look at the odds on that, I think the odds are extremely high that there is life somewhere out there. There are billions and billions and billions of stars with billions and billions and billions of planets around those stars. The odds are very good that there's something else out there. Is it identifiable? Is it smart? Do you need to have a microscope to see it? Who knows? But I think the odds are with it that there's something out there. I haven't met it yet, but I think our job as a species is to get out there to develop the capability and potentially go find it or maybe meet life somewhere out there.
Fair enough. And finally, what advice do you have for current or potential CMU entrepreneurs?
Well, for CMU folks that want to get involved with space, I'd highly recommend going and talking to Red Whitaker down in robotics. He is the grandfather of this. He's been around so long, knows all the ins and outs. He really is the visionary that can cast you in the right direction. And then, of course, also keep an eye on job openings at Astrobotic. We're right down the street from Carnegie Mellon. So as your career is coming to the end at Carnegie Mellon, definitely take a look at Astrobotic because we're looking to hire almost all the time.
Absolutely. Thank you so much, obviously. This has been a fantastic conversation.
Well, thank you. Appreciate it. Thanks for doing this and thanks for telling our story.
Absolutely. Absolutely. Have a nice day.
All right, you too. Take it easy.
Thank you for watching this episode of the Entrepreneur Interview Series presented by the Undergraduate Entrepreneurship Association at Carnegie Mellon University. That was Mr. John Thornton, CEO of Astrobotic. You can find out more about Astrobotic by visiting astrobotic.com, and you can become involved in space robotics at CMU by contacting Mr. Red Whitaker at red@cmu.edu. For the entire CMU UEA, I am Nix Pawlowski, wishing you good luck on all your future ventures. Thank you.